Today we are working on multiplication properties. Please copy down the standard benchmark indicator on a clean page in your math notebook. The student will create and solve problems involving the multiplication of whole numbers using pencil and paper, estimation, and mental computation. Exploring multiplication patterns and properties. Commutative property. When you commute from home to work by train or car, the distance you go back and forth is the same. The distance stays the same no matter the order. This means with numbers, we can change the order to make multiplication easier for us. So here, they switch the order of the 10 and the 2, just to help them multiply easier. We can also use the associative property. When an association meets, members can group themselves in different ways, but the association stays the same. It's the same group of numbers. So on this one, first thing we did in the commutative property is we switched the order of the 10 and the 2. Then, in this next property, the associative property, we've now moved the parentheses. So the two numbers we're multiplying first are 10 times 10, which we know is 100, and 100 times 2 gets us 200. So we can use the properties to make solving more complicated equations easier. So in our example here, we can make solving 4 times 7 times 25 easier. Right now they have 7 times 25 within the parentheses. That gets us 175, which multiplied by 4 is hard to do in your head. What you can do is first use the commutative property to change the order. So we flip the order of the 25 and the 7. Then we use the associative property to change the grouping. We shifted the parentheses from around the 25 and the 7 to around the 4 and the 25. 4 times 25 is 100. 100 times 7 is 700. That is a lot easier than multiplying 175 times 4 in your head. So it makes it much easier for us to do mental math. So find each product. Use multiplication properties. So first we have 7 times 5 times 40. So what they want us to do is shift the parentheses, so use the associative property to put the parentheses around the 5 and the 40 now. Now we can multiply 5 times 40, which is 200. And then 7 times 200 is 1,400, which is a lot easier to do in our heads than trying to multiply 35 by 40. For 2, we've moved the parentheses again, so we've changed the association using our associative property to around the 100 times 30. So we're going to fill in the 30 and the 7 in their new locations. Then we do 30 times 100, which gets us 3,000. And then 3,000 times 7 is 21,000. For 3, we can use our commutative and our associative properties. So if we want to multiply the 8 and the 3 together first thing we're going to do is shift the order of the 10 and the 3, and then we're going to shift the parentheses up to the front. Now we can do 8 times 3, which is 24, times 10 is 240. For 4, if we look at it, multiplying the 40 times the 5 makes sense because we already know that's 200. So we're going to get 30 times 200. And we know 3 times 2 is 6. And then we need to add the 3 zeros from our factor. So 30 times 200 will get us 6,000. For 5, we're just going to shift the parentheses up so we can do the 50 times 4 first. And then 50 times 4 gets us 200, and 200 times 2 is 400. For number 6, we're going to shift the parentheses back to do the 70 times 10 first. Okay, then we know 70 times 10 is 700, so we get 8 times 700. And we know 8 times 7 is 56, so 8 times 700 is 5,600. The third property we're looking at is called the distributive property. The distributive property lets you break up numbers before you multiply. So to multiply 2 times 126, we can break 126 into 120 and 6. So if you look down here at the bottom, we now have 2 times 120 plus 6 in parentheses. This is called the distributive property because we're going to distribute the 2 to both numbers. So we get 2 times 120 and then 2 times 6. So 2 times 100 is 240, 2 times 6 is 12, and then we add those two partial products back together, and we get 252. So the distributive property is a good way to mentally break large numbers into smaller pieces, so you can do the math mentally. For number 1, we have 3 times 18, so we're going to break 18 apart. And you always want to look for big round numbers when you're doing this. So 10 is a nice round number. So we're going to have 10 and 8 as our two numbers. And then we distribute the 3. So we get 3 times 10 and 3 times 8. So 3 times 10 is 30. 3 times 8 is 24. Then 30 plus 24 gets us 54 for our answer. For number 2, we have 253 times 4. We're going to break 253 apart into 250 and 3. So then we distribute the 4 out, so we get 4 times 250 and 4 times 3. 4 times 250 is 1,000, and 4 times 3 is 12. Then we just add our partial products together, and we get 1,012. For 3, we have 404 times 2. So we're going to break the 404 apart into 404 and then distribute the 2 across. Now we have 2 times 400, which is 800. And then 2 times 4, which they've already filled in for us, which is 8. So then we just add the two partial products, and we get 808 as our answer. For 4, we have 8 times 128. So we're going to break 128 into 120 plus 8. Then we're going to distribute the 8 across, so we get 8 times 120 and 8 times 8. We know that 8 times 8 is 64, and then we're going to add the two partial products, which gets us 1,024. With the distributive property, you can also use subtraction. So I'm going to take problem 4 again and show you how to do it using the subtraction method. So in that case, you're looking at what's the closest number to 128 that's a nice round number. So we're going to go up to 130. So now it's going to become 8 times 130 minus 2, because 130 minus 2 is 128. So now we're going to distribute the 8 across. And if you're thinking, okay, 8 times 130 in my head is kind of tricky, you can break it further apart into 100 plus 30. So then you get 1040 minus 16, which gets you 1024. The exact same thing we did before, it's just using subtraction instead of adding for the distributive property. Both are acceptable ways to use it. Please make sure you have all the work copied down, including this example, and glue your page into your math notebook.